Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 3rd, 2025, about 5 days ago. This paper proposes a two-player adversarial setup that checks only the most likely failures, lifting quality while slashing verification, with factual biography fact score reaching 0.889 as validator calls drop from about 439,000 to about 77,000, roughly a 5.7 times reduction, and in code, pass 1 scores up to 56.6, using about 192,000 tests versus about 7.86 million, roughly 98% fewer. The paper is titled RLAC, Reinforcement Learning with Adversarial Critic for Free-Form Generation Tasks, and the implications for model training are quite significant. Alright, Figure 1 contrasts 3 post-training setups for a biography prompt. The left panel depicts enumerative verification that extracts many facts and checks each one, which yields accuracy but heavy verification cost. The middle panel illustrates a reward model that assigns a scalar score without verification, so it risks reward hacking. The right panel presents RLAC, where a critic proposes one likely wrong fact that an external validator checks, and rewards flow to the side that proves correct. Well, Figure 1 contrasted the training styles. Table 1 reports the factual biography results. RLAC delivers the highest fact score across all settings while slashing validator calls, which signals both better quality and lower cost. With QN38B at 8 sentences, fact score reaches about 0.889, with roughly 76,000 calls, versus FactTune FS at about 0.867, with roughly 439,000. Incorrect facts also drop, for instance to about 3 on QN38B. So, while Table 1 reported headline gains, Figure 2 explains why they emerged. The left panel shows training dynamics where RLAC climbs toward about 0.89 fact score, surpassing FactTune FS and leaving ARMO-RM plateaued. The center panel plots verification efficiency, with RLAC reaching high factuality after far fewer calls. The right panel tracks exploration. KL divergence grows with RLAC as factuality improves, which signals productive exploration rather than reward hacking. Alright, the previous figure highlighted efficiency gains. Table 2 compares critic types on factual biography accuracy. The adversarial critic yields the most correct facts at about 21.6 and keeps incorrect around 4.8, giving a fact score near 0.82. The static critic posts the highest fact score at about 0.83 because it slashes incorrect to roughly 3.8, though it answers fewer facts correctly at about 17.8. A noisy validator degrades both correct and overall score, while the base model trails on every metric. So the previous table compared critic types on accuracy. Figure 3 shows how supervision strength evolves over epochs, with mean return reflecting how often the validator approves a proposed failure, which means weaker supervision at higher values. The static critic rises steadily toward about 0.8, signaling growing misjudgment of correct facts. The adversarial critic stays markedly lower, peaking near 0.58, which indicates tighter calibration and fewer false alarms as training proceeds. So the previous figure showed supervision trends. Table 3 reports code generation benchmarks across Human Eval, MBPP, Big Code Bench, Complete and Instruct, and Live Code Bench. RLAC leads the averages with about 53 and 57 for the base and instruct backbones, which beats ACE Coder Rule at roughly 52 and 56. RLAC also posts strong per column scores, like about 35 on Live Code Bench, and around 21 and 24 on the hard Big Code Bench splits. These gains matter because they arrive with far fewer validator calls. Okay, the previous table reported broad code gains. Figure 4 compares static and adversarial critics over training rounds. The left panel shows detection precision, where the static critic slid from about 42% to roughly 34% as the generator exploited fixed patterns, while the adversarial critic peaked near 46% and held around 40%. The right panel tracks Human Eval Pass 1, which rose steadily for the adversarial critic to about 0.933, whereas the static critic barely moved around 0.92. The takeaway is that a dynamic critic sustains detection and translates into higher task scores. 2 takeaways stand out. A dynamic adversarial critic can target the most likely failures, which lifts factuality and code correctness while cutting validator calls by orders of magnitude, and the setup resists reward hacking by keeping supervision verifiable and prompt-specific. The broader implication is scalable, cost-efficient post-training for free-form generation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.